So you remember I was telling you earlier in the week, Tiago is joining us for this class. So treat him like a student, okay? He's here to learn some physics too, alright? Okay, so we'll continue now. Workbook. Physics. Electricity. Okay. Now, we'll see how we get on with this topic. It's very important for the exam. Hang on, what's going on here? Okay. So as I was saying, this topic is very important for the exam. Usually this makes up a section B question. Now, it's one of those topics which, at first, I think you won't like it. Most students don't like it at first. But I really think it's actually a nice topic. It's a good topic. It's a little bit difficult at first. But once you get over that, you will realise it's a good question in the exam. You know, it's I guess it's kind of a little bit like calculus and maths. You know, it's hard at first, but then with practice it becomes a nice question in the exam. Right. Now, my laptop's a bit messed up. How do I do presentation mode? Yeah, where is that? View full screen? There we go. Okay. I'm curious before I start how you would pronounce his name.
Kirchhoff.
Yeah, that's what I'd say. Tiago, what would you say actually for this name? How would you pronounce it?
I'd say Kirchhoff.
Yeah, I hear so many different pronunciations. I think Tiago might be the closest to it. It's a Russian name. Yeah, but out of habit I keep saying Kirchhoff. So it doesn't, I don't mind too much. So we're going to look at Kirchhoff's laws anyways. There's just two of them. Okay. Right, have you got that written down? Kirchhoff? Got that? Yeah. Now, has anybody seen these before? No? No?
See the name.
Just the name, yeah. But you haven't seen the laws before? Okay. So there's two laws that we'll have a look at anyways. Okay, so Kirchhoff's first law is also called the junction law. Basically, it says, oh, George, yeah?
Yeah.
Come on in, so. So Kirchhoff's junction law says that at any junction in a circuit, the total current flowing in is equal to the total current flowing out. So as a formula, you can write it like this. And I'll explain in a moment exactly what that means. Yeah. Don't worry, I'll explain what this means in a moment, if you just want to write it down first. Looking for me? Oh, no, you...
Apologising for sending students too late.
No, that's okay, that's okay. Yeah, thanks for that. Now, in the exam, they sometimes ask for the definition. So, again, like with some of the other definitions, you can give it in words or you can give it as a formula. But of course, if you give it as a formula, you have to explain what each part of the formula represents. You've seen this symbol in maths? Yeah, what's it mean? Sum, yeah. What Greek letter is it? Which Greek letter is this? Oh, you don't know? You could take a guess. Which Greek letter do you reckon it is? Yeah. It's their version of it. So what name is that? No? Now, I think you know this letter if I wrote it as the lowercase. You know this little Greek letter? Oh, it's not. This letter. No. This one's theta. Do you know this one? I think you do. It begins with an S. I think somebody knows it. Sigma, yeah. So that's sigma. No? Okay. Right, so let's explain what this means now. We'll give the picture and then we'll just explain this formula. So, it's actually similar to a rule we did previously. It says if you have a junction, like here, and you're looking at the current that goes in, so let me call that I1, and you're comparing that to the current that comes out, let's call it I2 and I3. Kirchhoff said I1 should equal I2 plus I3. Okay. Now, if you call in positive and out negative, or in other words, if you write it like this, I1 minus I2 minus I3, this should end up equaling 0. Which is just what Kirchhoff says here. If you add up all the currents, the total should be 0. The only condition is that in you give as a positive and out you give as a minus. But it amounts to saying that the current in equals the current out. Okay. Now, this is actually a result of the conservation of charge. Again, something that we saw. So, for example, if 2 coulombs go in, then 2 coulombs must come out. In the exam, what they like to do is give you 2 parts. Part A is what is Kirchhoff's first law, and part B, what is it the conservation of? And Kirchhoff's first law is due to the conservation of charge. So you should note that with the law, due to conservation of charge. Okay. Continue? Do you all have that? Yes, Chow? Continue? Yeah, okay. So I already drew that. Okay, so Kirchhoff's second law is called the loop law. And it says that the total voltage in a loop is 0. So it's kind of similar to the current. Now this one is not as easy as the last one to understand. So as soon as you write this down, we'll have a look at what that means in a diagram. Got that? Remember I was telling you last week my laptop's taking a long time to boot up. I was trying to fix it yesterday. So in trying to fix it, I made it slightly worse. So when I turn it on, previously I had to enter my password twice to unlock it. Now I have to enter my password 4 times. But the good news is it actually boots up a little bit faster. But I need to enter the password 4 times now. So I don't know how I did that. I really don't know how I did that. Okay, so let's have a look at what this means in a diagram. Okay, so suppose you have, where's my pen gone? You've got your cell, and let's say you have, I don't know, 1 lamp, maybe another lamp, goes back here. And say we'll stick a voltmeter here. So let's say this is, I don't know, let's say it's 2 volts. This one is 3 volts. This one here is 1 volt. I think you all have an idea of what the voltage of the cell must be. Yeah, it must be 6. Now, how did you get 6? You add them all up. Now if you think about it like this, is this cell providing or taken from the circuit? Is it given a voltage or removing a voltage? If you think about what a cell does. It's given a voltage. So we can think of this as like a plus. And these are taken. They're like consuming. So this is a minus, and a minus. So you could say 6 equals 2 plus 3 plus 1. Or you could say 6 minus 2 minus 3 minus 1 equals 0. Which is the same thing as saying the sum of the voltage is 0. Where things that provide get a positive value and things that take get a negative value. And this is actually the result of another conservation. Which conservation do we think this might be the result of? Yeah, but from something we did in mechanics. It's a conservation of voltage, correct, but from something we did in mechanics, it's similar to some other conservation. Yeah, conservation of energy, good. Because it's like the energy this provides equals the energy that these consume. So Kirchhoff's second law is a result of conservation of energy, if you want to add that in. Got that? So you haven't seen these laws before. A lot of high school students don't do these two laws. They're a little bit more advanced. Okay, continue. You have that? Yep. Okay. Right. So I already drew that for you. Okay, so before we actually look at using Kirchhoff's laws, some advice, some tips. So don't forget, you can still use the formula V equals I or. And in fact, when using Kirchhoff's laws, this one becomes very useful. Because in the last one, we're looking at voltages. Often in the question, we don't know the voltage, so it's good to replace it with I or instead. So you can still use V equals I or. Tip number 1. In fact, it's used very often. Okay. Usually I discovered in the exam questions, you only need to use the junction rule once. So often you need the junction rule once and the voltage rule more than once. That's what I discovered. Often the loop rule more than once, junction rule only once in exam questions. The first one is the junction, and usually questions only need that one time. And then the loop law, it needs, usually in the exam, 2 times, the way they designed the circuit. If the loop goes the wrong way through a battery or a resistor, then the voltage flips sign. So let me explain what I mean by that. Okay, so here you have your cell. Which way is the current going? To the left or to the right here? To the left, okay? So let's say this is 6 volts. So this will provide 6 volts. What do you think happens if you try to move backwards the wrong way through it? Are you going to gain the 6 volts if you're forcing your way back through it? No, you lose them. So instead of being a plus 6, it's a minus 6. Now, this should remind you of what we did last time. Remember we said if you have the AA batteries and you put them in the wrong way around, what happens to the voltage? It reduces, yeah. It could go down to 0. And the same thing happens with the resistor. So here's the resistor. If I move through it, am I gaining or losing energy? Losing energy, okay? So you would lose, for example, 6 volts. But what happens if I move myself the wrong way through it in the picture? Then actually it's a gain. This is where it's most likely to make a mistake with the sign when you're moving the wrong way through something. And we'll have a look at that in an example. You can choose any loop in the diagrams, but my advice is it's easier if you choose a loop that has a cell in it, because it gives you somewhere to start. And it's easiest to go with the flow. So what I mean by that is, here's our loop. So we should look at the loop this way, because it's going with the flow rather than the other way, which is a bit more awkward. Okay. So like if you have here, let's say I have two loops. This loop is a little easier to look at than, say, this loop, because it has a cell in it. I'm not saying you can't look at this one. It's easier for me to look at these ones. Anyways, these are all just general advice. It becomes much clearer when we have a look at an example. Alright? Yes, an example is definitely needed. Okay. So we're going to have a look at this one. However, this one should look familiar. We did this one last time, didn't we? Except it took us kind of a while to do because we had to simplify it and combine and break it down. We can see how useful Kirchhoff is here now. So let's draw this and apply Kirchhoff's rules to it. So we've got a 1 ohm, 2 ohms, 1 ohm, 2 ohms, 3 ohms, 4 ohms, and then in the middle here we've got a 5 volt cell here. Okay, so we'll call the current that comes out I1. Current moves along here and then it splits into two currents. So we'll call the current here I2 and this one here I3. Good, okay. So this is I2, this is I2, and this is I3, and this is I3. Well, what do we get back here? I1, because that's what it was on this line. It came out as I1, so it goes in as I1, so that's I1 as well. Okay, let us use Kirchhoff's first rule, the junction rule. So here's our junction. What current is going into this junction? I1, I2, or I3? What's going into the junction? I1. And what's coming out? Which one? I2 or I3? I1, I2, I3. What's coming out of the junction? I2 and I3. So it's minus I2 minus I3 equals 0. Okay, that's from Kirchhoff's first rule. Now you might get a feeling of what's going to happen here. How many unknowns are in this equation? 3. I1, I2, I3. So how many equations do you think we'll need to form? 3. And you recall I said we usually only need the loop rule once. So the junction rule once. So we need 2 loop rules now. Okay, so we actually have 3 loops we can look at. We can look at this loop. Yes? We can look at this loop. Or we can look at this loop. We have 3 loops. So which loop will I take first? Well, let's start with the cell. So I start with this one here. And I'll go down here, left, up, and back to the start. Okay, this 5 volts, is it providing or taken? Providing. So we'll start off with plus 5. Now I move along here. What happens to my voltage when I move through the resistor? Increase or decrease? Decrease, so minus. Now what is the voltage here? Do we know? No, because we only have the resistance, right? But remember we have V equals I or. Do we know the or? We do. What is it? 3. And the I is, which I? I2, isn't it? So it's 5 minus 3 I2. I2, 3, yeah. Okay, and now I move up here. What voltage do I lose here? Minus what? 4I2 equals 0. So that's a second equation. One more equation to go. Let's go the other direction. Start here and we'll go up. Okay, so what do I write down first from starting here? And I'll go this way. I'll go the same direction. So it'll be plus 5. If I went up this way, it'll be minus 5, yeah. Plus 5, okay. Next. What happens here? Plus or minus? Minus 2I3. And then up here? Minus I3. Yeah, 1I3. Equals 0. Right. Have you seen a problem like this in maths? What does this remind you of? Which lesson in maths class? You have equations with unknowns to solve. Substitution method, yeah. What's the name of this lesson? A long time ago? Simultaneous, yeah. Except I think with Joan you probably only had 2 equations, yeah. So we'll have to see how to do it with 3. So before I continue, I'll just give you a minute to write these equations down and we'll look at solving them. Now these ones actually aren't too difficult to solve, because if you look at it, what could we get from this? What could we find here? Could we solve for I2 here? Could we figure out I2 here? We could, couldn't we? Yeah, what could we get from this guy? I3. If we know I2 and I3, what could we get from this guy? I1. Okie dokie. Nearly got that? Have that, yeah. You have this? Yeah. So, if I look at the second equation here, I could say 5 equals 7i2. Because minus 3i2 minus 4i2 is minus 7i2. I take the 7i2 to the right and I get this. So therefore, what's i2? It's 5 over 7. 5 over 7, yeah. Could you just hit that in 5 over 7? Yeah, what do we get?
0.714.
714 amps. This one here, I could say 5 equals what? 3i3. So that means i3 equals 5 over 3. So what's that there? 1.6, isn't it? Recurring, yeah, 1.67 amps. And then in the first equation, you could say I1 equals I2 plus I3. So if you could add these two together, please. 0.714 plus 1.67. What's that now? 2.38 amps, we'll say. Now, I want you to flick back to when we did this last time. Did we get the same answers? Have a look. These seem familiar numbers, don't they? Exactly the same? Yeah. Which method was easier, though? Much easier, right? Much quicker. Right? You don't think so? You prefer the previous method? Really? Alright, okay. I like this method because it's more mathematical. You change the problem into a maths problem. Is this why you don't like it? No? Ah, familiar, okay. It's because this is new. Yeah, okay. Right, continue? Yeah. That was kind of an easy circuit. Let's have a look at another one. Right, now that's a much more interesting circuit. So I'll just give you a minute to draw this, and then what I usually do is I'll ask one of you one by one to form the equations. Yes. Can you see it okay? This is A, B, C, D, E, F. This is total 12, total 6, 4, 4, 16. Do you remember doing this, Diego? Is this familiar stuff? Yeah. Happy memories or?
Not that much. It was my last preferred topic in physics.
Really?
Yeah.
Wow, okay. Most preferred topic?
It's more like mechanic and...
Do you know what's funny? I think that's their least preferred topic. Is it mechanics?
Really?
Yes, yes.
And thermodynamics.
And thermodynamics, yeah, okay.
Optics was okay, but...
Yeah, we don't do optics in this course. The lenses and mirrors and all that.
Yeah,
we don't cover, yeah. Okay, have you got that drawn? Can you see okay, Kim? Which, do you need me to, this is 12? Oh, this one is I1? Is it? Oh, this A, B, C, D, E, F. Can you see okay, Joe?
Which A?
A, B, C, D, E, F.
A, B, C.
Good. Okay, so I'm going to ask you one by one for each of these parts, and then we'll solve the equations together at the end. Yes? Are we all ready? Not ready? Well, could you multitask if we do two things at the same time? Okay. Kim, I'll start with you. So if you look here, I want the junction rule at B. So this is B here. So tell me which currents are going into B. Now I'll help you out here. This is I1, so this one up here is I1. This is I2, so this way around is I2. And down here is I3. So what is going into B? Which currents? Which one? I1, 2 or 3? I1 is going in. And what else? Another one? I2, good. And coming out? I3 is coming out. So what equation could you make? Yeah. Yeah. Yes, correct. I1 plus I2 minus I3. Yeah. Equals 0. Good. Can you write that down as the first one? I1 plus I2 minus I3 equals 0. Got that? And you're going to give us the next one now. I want the junction rule at E. Here's E here. What's going into the junction at E?
I1.
Yeah, here's I3, and then I1 is this way, and then I2 is this way.
It's going to I1 and I2.
I1 is going left, I2 is going right, and I3 is going down. So what's going into the junction, would you say?
I3.
I3, good. And coming out?
Coming out. I2 and I1.
Yeah, so what's the equation you could make?
I3 goes to I1 plus I2.
Yeah, let's just make it with the minus then. So just rewrite that a little bit. You could say I3 minus I1 minus I2. Yeah. So can you write that down? I3 minus I1 minus I2 equals 0. No. Siva, for the next part, what have you noticed about these two equations? So the equation that Kim got and the equation that Andek got. Anything you can notice about the two of them? That's the only difference, isn't it? So really they're the same equation, just one of them has a sign split. Okay. Right, so loop now. A, B, E, F. Right. Do you think we should ask Tiago to give us the next one? Think you can have a go, or we'll skip over you?
I think I would skip.
Okay. So we'll go down to you then. So I want the loop from A, B, E, F then. So where would you start in this loop? The A, B, E, F loop. Where should I start? Should I start here, or at the start?
Actually,
Oh, but I mean, should I start at the resistor, or the cell?
start the cell and
Start at the cell and go up or down?
go up.
Good, okay. So if we start here, is this adding or taking?
And
It's adding, yeah. So our equation is 12. Alright, now we're here. Minus, yeah, minus what now?
minus I1.
Yeah, 4i1.
Yeah, like negative I1.
Yeah. With the 4. Yeah. So 12 minus 4i1, and then the next one?
Minus 16 I3.
Very good. So 12 minus 4i1 minus 16i3 equals 0. Can you write that one down? 12 minus 4i1 minus 16i3 equals 0. Got that? Yeah? You got that, Chow?
Yeah.
Yeah, okay. Matt! Matt, you're going to give us the loop CBED. Whoops. CBED. No, this loop. So where do you want to start in this loop? Yeah, 6, yeah. Up or down?
Up.
Okay, so 6, yeah.
Minus 4I2.
6 minus 4i2
Minus 16I3.
minus 16i3
Plus 0.
equals 0. Can you write that down? 6 minus 4i2 minus 16i3 equals 0. Okay, Chow, we're going to give you the hard one. The loop A, B, C, D, E, F. So that's the big loop on the outside.
Yeah.
Yeah. Where do you want to start?
Okay.
Yeah, where do you want to start? You can start here, 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 or here. You have 4 places.
12.
Let's start with the 12. Good, okay. So is this a plus or a minus?
Plus.
Plus, okay. So 12. Next.
Minus 4i1.
Sorry. Minus 4i1. Good. Next.
4i1.
Plus or minus?
Minus 4i1.
I think this is an I2 here. You're going along the top, yeah?
Yeah.
This is I2 for this one.
Okay.
So you have 12 minus 4i1, and then next?
Minus 4i2.
Yeah, but it's not minus. Yeah, so something strange has happened here. Which way is the current in this picture? Going left or going right? Going left. Can you see? The current is going left here. Yeah? But which way are you moving? You're moving right.
Yeah.
You're moving the wrong way. So you have to change the sign. So it's instead plus 4i2.
Plus 4i2.
Yeah. Yeah. Because you're going backwards. You're going the wrong way in it.
Okay, so.
Yeah, this is where to be careful. So you have 12 minus 4i1 plus 4i2.
4i2.
Now think carefully for the last one. I get to here.
Plus.
Sadly, minus 6, yeah. Because you're going the wrong way again. You see? You should be going up. Because if you have this,
Yeah.
which way does the current go? It goes up.
Uh-huh.
This is plus, this is minus. And which way are you going? Down.
Down.
The wrong way. So instead it's minus 6. Yeah. Wonderful. So how many equations do we have? We have a lot, don't we? But how many do we actually need? 3, because there's 3 unknowns. So we need to pick 3 equations. So we might as well use one of the junction ones, and then 2 of the loop ones. So let's write down the first one. So Kim, what was your first equation? We'll use that one. I1 plus I2 minus I3 equals 0. Okay, give us another loop one. Which is an easy loop one? Is the first loop one easy enough? Yeah, who gave me the first loop one? Who was that? It was you, yeah, you give me the first loop one. What was your loop one there, George?
12 minus 4I
Yeah.
minus 16I3 equals 0.
4I1
Yeah,
minus 16
I3.
I3 equals 0. And then, Matt, we'll use your loop one. What did you have?
12 minus 4I2
Yeah,
minus 16I3
equals
equals 0.
0. Okay, now, let's solve this. Not as easy as the last one, right? Any ideas on how we could solve this? What method could we use? Elimination, yeah. Now, which should we eliminate first? I1, I2, or I3? Which one? I3? Correct. Why though?
It's negative.
Oh, okay. Another reason.
Yeah, see,
You're saying?
that's it, yeah. See.
Good. Yeah. This is important. You should only eliminate what's in all of them. And there's only one letter that's in all of them, I3. So we're happy we have 16I3 here and 16I3 here. But these numbers, I can clean them up. What can I divide by? I can divide by, what's in common? 4. Divide by 4. And multiply here, if I want to make them the same? 4, yeah, okay. So we have here 4I1 plus 4I2 minus 4I3 equals 0. Here we have minus I1 minus 4I3, and then 12 divided by 4 is obviously 3, but I'll just bring that to the other side, so it becomes minus 3. And then the last one, that would be minus I2 minus 4I3, and then 12 divided by 4 is 3. I bring it to the other side again and I get minus 3. Now, should I add or subtract these? Plus or minus? Should I add them or minus them? Minus them. And then these two, minus as well. So let's do that one. 4I1 minus minus I1. What's that? 5I1. 4I2 minus no I2s. That's still 4I2. Minus 4I3 minus minus 4I3. 0. 0 minus minus 3. 3. Good. Minus I1 minus no I1s. Minus I1. No I2s minus minus I2. Good, good, good. I3s. Cancel. Minus 3 minus minus 3. 0. Alright, this is much easier, isn't it? You have just two equations, right? What can I do here to solve? What should I do next? Yeah, or another multiplication. Yeah, okay, everybody wants to do substitution, fine. So you can say here I2 equals I1. Yeah? And then what will I do with that? Sub it into that, yeah? So I get 5I1 plus 4I1 equals 3. So that's 9I1 equals 3. So what does I1 equal? 1 over 3 amps. And then because I1 equals I2, what does I2 equal? 1 over 3 amps as well. And then how can I get I3? I could use this equation. I3 equals I1 plus I2. So then what would I3 equal here? 1 over 3 plus 1 over 3? 2 over 3 amps then. Yeah? Are we liking Kirchhoff or not liking Kirchhoff? Not liking Kirchhoff. Really?
I mean, it's just forming the formulas, that's it.
That's half the... No, that's actually most of the work, isn't it? I know, I can see you don't like it.
What's the 12 minus 4I1?
12 minus 4I1.
And again 12 minus 4I2.
Yeah.
What is this here?
Oh, this, George gave me this one, and Matt gave me this one.
It's 6 minus 4I2. No?
What? Which one is the 6?
The last one is 6 minus
Oh,
4I2.
Matt, you told me it was 12.
The big group.
Oh, no, I wanted your one, not Chell's one.
So minus.
So this is right. This is your equation. 12 minus 4i2 minus 16i3. Yes? Okay, fine. And
No.
no, oh no, all right. What's wrong with it? Which number's wrong? That should be 12 should be a 6. Because you know what that means now, don't you? All right. So look, that's real life. This happens, you know. Try not to do that in the exam. This should have been a 6.
Oh, no, it's clear.
Now it all makes sense, huh?
Yeah.
Okay. No, there was a miscommunication there, but that's okay. I don't want to mess this up by changing it. So we'll just pretend that those were the 3 equations then, okay? Because really what matters to me is that you know the steps for solving it. Of course, try not to do this in the exam. Double check before you begin. Okay.
I don't know. Method to solve these 3 equations.
Yeah, but this is the easiest. This is, trust me, is the easiest. I tried other methods in previous years, but they're not as easy as this. So the tip is you match one variable up and eliminate it from all 3 at the beginning. Yeah. Continue? Okay. Let's be a bit more careful with the next one. So let's see, how are we doing for time? Yeah. So anyway, Tiago, my idea is I'm going to run through more examples. So you're welcome to stay, but I know you could only stay for the one class, was it? So if you wanted to leave now before I start the next one, or if you want to wait, it's up to you.
I will watch just one more.
One more, okay, all right. So we'll do the same thing again here, okay? I'll ask each of you for an equation, and then we'll solve them. So if you can draw the circuit, and then I'll ask you one by one for an equation. Now I should tell you that this was an actual exam question. And it was worth a lot of marks. I think it was like, I think it might have been like 12 marks. That's a lot, 12%, you know. I know it's good. Because I don't think you have to work too hard to get that 12%, right? Like, think about how much work you have to do in a mechanics question to get 12 marks. Now, if you can't see, that's an I1, that's I1, that's I2, that's I3. Okay, shall we start? Are you ready? Yes, we'll start. Chow? That's I1, that's I2, and that's I3. 1, 2, 3. Okay, we'll take the reverse loop this time then. So we'll start with Chow then. Chow, do you want to use a loop rule or junction rule? Your choice. Loop or junction first?
Loop?
You want to use a loop rule. Okay? Which loop do you want to use? So what loop do you want to take? Your choice. Left?
Left.
Yeah. Where do we start? Start at the 50?
50, yeah.
Okay. So listen carefully, write Chow's equation down. So go. 50?
Plus.
Yeah, plus 50, yeah. Next?
Minus 10I1.
Yeah, minus 10I1. Next?
Minus 5I1.
Good, minus 5I1. Now, are you going right or down? What do you want to do?
Going down.
Going down. Okay, next? That's a 4 and that's an I3 if you can't see.
Minus
Yeah?
4.
Good, minus 4.
3.
Minus 4i3
Yeah.
equals 0.
Equals 0.
Equals 0. Okay, good. Right. Matt, loop or junction rule next? What do you want to use? Another loop. Okay, fine. Where do you want to start?
Right.
And start at 4. Okay, go ahead.
4 minus 3i2.
Good. 4 minus 3i2
Minus 2i2.
minus 2i2
Minus 4i3.
minus 4i3
Equals 0.
equals 0. Right. George, they both use loop rule, so you have to use a junction rule. So where's the junction that you're going to look at?
5, 2.
Yeah, you've actually got two junctions, the top and the bottom junction. So which one will you look at?
Bottom.
Bottom one. Okay. So what's the formula here?
I3.
Yeah.
Plus 50.
Oh, you're doing another loop.
No.
Yeah, I want the junction one. You know where you say the current in minus the current out. So what current is going in here?
I3.
I3. And what's coming out? So it's kind of hard to see, but it's an I1 that's coming out. And this side there's an I2. This side is the I2 side. And you can see this one here is the I1 side. So, yeah, go ahead there.
Wait, I'm confused with the junction rules.
The junction rule is a bit confusing for you. So what you do is you say the current in minus the current out equals 0. So which is going in, I1, I2 or I3?
I3.
I3. And who's coming out?
I1.
I1 and I2. So what equation will you make then?
I3 equals I1 minus I2.
Yeah, I think you meant to say I3 minus I1 minus I2 equals 0. You confused or? Yeah. Will I draw it? I3 going in, I1 and I2 come out. So you can say I3 minus I1 minus I2 equals 0 because that's an in and they're outs.
Yeah.
Is that okay? Are you sure?
Yeah.
Okay. Right. Let's carefully solve those equations and please read them to me carefully. So, Chow, read your equation to me carefully. What did you get? Your equation. Read it back to me. What was it? What?
50.
50. Are you sure?
Yeah.
50. Okay, go on.
Minus 10i1.
Yeah?
Minus 5i1.
Yeah?
Minus 4i3
Yeah?
equals 0.
Now, before we continue, can you all double check that that's right? Are you sure? Yes? Okay. So, we can just clean this up. We can say it's 15i1 plus 4i3 equals 50. If I just take it to the right. Okay. Who gave me the second one? It was you, wasn't it? Matt, what did you get? Careful now.
4
4, yes?
minus 3i2
Yeah?
minus 2i2
Yeah?
minus 4i3 equals 0.
Okay, so how could we clean that up? We could say 5i2 plus 4i3, yeah, equals 4. Are we good with that? If I take everything to the right? Looks okay, yeah? And you gave me the last one, George. What was your one there?
I3 minus I1 minus I2.
Yeah, so you said, so that's like saying minus I1 minus I2 plus I3 equals 0. Alright, wonderful. Let's solve. So we have 15i1 plus 4i3 equals 50. We have 5i2 plus 4i3 equals 4. And we have minus I1 minus I2 plus I3 equals 0. Okay, what can we eliminate first? In fact, it's only I3, isn't it? And how will we do that, Siva? What's your idea? We have to subtract, but first we have to do a multiplication. There's a problem. This I3 is not the same as the other two. Yeah. 4, 4, and 4. Okay, so let's subtract. I minus these two, and I minus these two. 15i1 minus no i1s. Okay, 15i1. no I2s minus 5I2s, minus 5I2. 4I3 minus 4I3, it's gone. And 50 minus 4, 46. Right. 5I2, sorry, no I1s minus 4I1. 4I1. 5I2s minus 4I2. 9I2. 4I3 minus 4I3. It's gone. 4 minus 0. 4. Right. This is kind of ugly numbers. What would be the best thing to do next now? We could cancel. Will we cancel I2 next? Cancel I2? What should I multiply here and here? 9 and 5, huh? Right, 15 times 9, what's that, 135, is it? Double check that. 135 by 1, minus 45 by 2, 46 times 9, what's that, 414? Okay, good. 4I1 times 5, 20I1, plus 45I2 equals 20. Right, what should I do next? Add or minus, plus or minus? Plus. That's 155I1 equals 434. Right, well the good thing is we have I1. 434 divided by 155, 2.8 amps. Beautiful. What will be the easiest equation for getting I2, do you think? Will we sub it back into this guy? Yeah. 4 times 2.8 plus 9, I2 equals 4. So I2 is 4 minus 4 times 2.8 over 9. So what do we get for I2? It's going to be negative, and that's fine. I'll explain what that means now. What did you get? Positive or negative? Negative 0.8 amps. And finally, what's the best equation for getting I3? I think we'll use this one here, yeah? So you can say I3 is just I1 plus I2. So what's I3 here? If I add these together, it's just going to be 2 amps, isn't it? Yeah? Got that? Now, do you notice how I didn't actually look at what the question asked me to do next? Because there's only one thing they can ask me to do. Figure out I1, I2, I3. So now let's have a look at the question. What is I1? Did we work out I1? We did. Did we work out I2? We did. And did we work out I3? We did. We did all 3 parts at once. We actually did part 4 as well. What direction will the electrons move in the 4-volt power source? Okay, so if we look at this one, what current do we have here? I2. Now, this is why they asked you about it. Because I2 is negative. Now that's a little bit strange. Because what that is telling us is that the picture is wrong. It looks like the I2 is going up in the picture. But because we got a negative answer, what does that tell us? It's actually heading down. Now, be very careful. If the current is heading down, which way are the electrons moving? Up. Because we said they move opposite to the current. So the answer for part 4 is up. Yeah. Now you can see why they picked that one, because it made you think a bit more. So if I remember correctly, I think the marks was something like, I think it was like 4441. I think that's what it was. So this here that I wrote on the board, this is worth 13%. That's pretty nice, I think. You know, Because like 13% could take you from one grade to the next grade. So this is why this is one of my favourite questions in the exam. It's why I really encourage my students to learn to like them. Because it gives you a very nice boost to your marks if you can do them. Yeah? Okay. So what I'm going to let you do, this is the last, oh no, I have two more examples. Wonderful. I'm going to let you try and do this one by yourself and then I'll do it. Okay, so give this one a go for a couple of minutes. I'll get your answers later for this one, Diego. I'll pop by.
No problem.
Are you in till 5?
Yeah.
Yeah, okay. I'll see you after lunch then or something.
Yeah. Thank you.
No problem. So this is another exam question. I took it from another past paper. Can you see these okay? 1, 2, 3. So you can see why this is a double lesson because I still have 2 more examples to do. So my tip is, guys, it's almost not important the way they ask the question. You're doing the same thing. You're making 3 equations and you're solving for the 3 variables. And they break it up as what's I1, what's I2, what's I3. But that's kind of fake because you kind of have to do the whole thing at once anyway. So, okay, so try this one, Chow, by yourself, and then I'll do it. You really don't. I really get a lot of hate for this over here. You don't like this as well, or you do like it?
No, I'm just hungry.
All right, fair enough.
This
Fair enough.
question is cost too much energy.
It does cost a lot of energy, doesn't it? Yeah. Is there anybody who likes this now, or it'll still take some time to learn to like it? It'll take some time, okay? Yeah. I'll be honest with you. My first year of teaching the physics here, this was my worst topic. I hated this one the most, but now it's my favorite topic. So trust me, you will learn to love it. Are you able to make the equations, George, or are you having trouble with them?
No, the arrows are.
A bit confusing. So just to be clear, if I look at this junction, okay, the I1 is going in and the I2 is going in, but the I3 is coming out.
Okay.
So you would say I1 plus I2 minus I3 equals 0.
So I said 7 minus 4I1, is it?
Yeah, 7 minus 4I1.
Is that it for I1 or
Say again?
is that the first equation? 7
Is
minus
it, no, you choose which one you want to start with. So you're doing a loop, is it?
Yeah.
So you're starting your loop at 7. So you have 7 minus 4I1 minus 5. No, just minus 5 volts. Because it's a cell, but you lose 5 volts because you go the wrong way in it.
And then
What
so
about the
can
I2?
you add
What about the
3i,
Yeah, what?
3i2 or minus?
Yeah, that's a good question. Plus or minus?
Minus.
Plus 3i2, so that's 3i1.
Minus
No,
three
plus.
I1.
Plus.
Plus
Because you're going the wrong way. When you move from this end to this end, you're losing. Because look at the way the current's flowing. The current is flowing this way. So moving this way is a reduction.
What?
See this here? Left.
I1 is go right.
Yeah, but you don't care because you're looking in this line, which is I2's line.
So it's plus 3I2.
Yes. Yeah. And then up here?
Plus.
Wait.
minus 2i1.
Yes.
Okay.
Okay, the love is starting to arrive now, yeah?
Why is minus?
The love hasn't arrived for everybody. Why minus up here? Because the current, you see the current here? The current is going down. So it's going left here. It's going left, down, right. So this is normal, going left. And we are moving left. So we are losing.
Sorry. So it's 7 minus 4I1.
Yeah.
And then minus 5 plus 3I2
Yeah?
minus 2I1.
Yes.
Oh.
Yes.
Why didn't we put any I's in the 5?
No, because you know you're looking at the voltage.
Oh.
So the reason you have the I's in the other one is because you're using the formula V equals I or. So it's actually also a voltage. Yeah.
So it's minus 5.
Yeah.
40 plus 3i2.
It's plus 3I2 because you're going through the resistor backwards. Which side is the in and which side is the out? The in is the right and the out is the left because the current is moving this way. No?
Is it I1 minus I2 equals I3?
I1 plus I2 minus I3 equals 0. Let me put it this way to you. I know it's a rectangle, so it looks like it's the same, but actually there's an inside and an outside, an in and an out. So the current is entering here and exit here. So it's like you take your car and you drive it in the wrong way. Everything's going to be flipped backwards. So instead of losing energy, you're gaining. Likewise here, you're supposed to go to the left, but if you drive your way in the wrong way, instead of getting that 5 volts, you actually lose it. It's like a reverse image. No? You don't like it?
What is the third equation?
Well, I think what have you used? Have you used the loop and a junction?
7 minus 4I minus 5 plus 3I2 minus 2I.
Okay, so you did a loop up the top. What was your second equation?
I1 plus I2 minus I3 equals
Good.
0.
Yeah. So why not loop the bottom? Here. You could go this way, see, but 5 minus 6I3 minus 3I2. Yeah, this line is I2's line. You don't like this, Ken.
So the equation for the junction, can it be I1 plus I2 equals I2?
It could be, yeah. I thought you'd all like this because it's mathematical. It's more like a maths lesson.
Yes.
Very
Plus
good.
3I2?
Minus 3I2, yeah.
But minus 3I2, yeah?
Minus 3I2, yes. Are you talking about this loop?
Yeah.
Yeah.
No 3I3?
So it's 5 minus
Minus
6I3
6I3
minus 3I2.
Minus 3I2.
Yeah.
What's your take?
Okay.
Now, before you solve, let's just make sure everyone has the same equations. So, look at me. Did everybody use a junction rule here?
Yeah.
So does everybody have I1 plus I2 minus I3 equals 0?
Yeah.
Good. Now, did most people use the 7? So 7 minus 4I1 minus 5 plus 3I2 minus 2I1 equals 0.
Yeah.
And then the bottom loop, 5 minus 6I3 minus 3I2 equals 0. You all have those three? Great, okay, so look at your three equations. Which can you eliminate? Which letter is in all of them?
3I2, 3I2.
I2 is in all of them?
Yeah.
Nothing else? Only I2 you can eliminate?
Only I2.
Okay, so eliminate I2 first, please. What's wrong, George?
Wait, so why the minus 6I3?
It's the usual story.
Yeah.
Yeah.
Okay.
Now, what I want you to do is eliminate I2, and then I'll ask you what equations you got. Have you produced two equations? Chow, have you cancelled I2?
Not yet.
Not yet. Do you know how to? You would cancel I2. Where's I2 here? I2 and I2. Okay, so this is 3I2, is it?
Mm-hmm.
So maybe you should multiply this by 3. And this is 3I2?
Yeah, it's 3I2.
Oh, that's it. Oh, so it's already 3I2,
Yeah.
3I2, 3I2.
Yeah.
So you should add these two and minus these two.
Why?
If you add these two, they'll cancel.
Mm-hmm.
And if you minus these two, they'll cancel. So you can make two equations.
Okay.
Yeah.
That's plus,
See,
yeah?
easy peasy.
That's plus this one?
Yeah? And minus those ones.
Minus this one plus
This one plus this one. Put the answer here. This one minus this one.
But if plus is 3I2.
Oh, I'm sorry. That's a plus and a plus, isn't it?
Yeah.
I'm sorry. So these are minus and these are plus. Yeah.
It's minus this.
Yeah.
minus I1 3
Have you eliminated I2?
Yeah, but
equals
it's a bit confusing about still working on it.
Yeah, but have you made the two equations?
Yeah,
Okay, now let's check if we all have the same two equations first.
2I1.
So, Siba, what two equations did you end up with after you eliminated I2?
I didn't eliminate.
You still have three equations?
2
Okay. Yeah?
The right side of 7 volts.
Say again?
The right side of 7 volts.
The right side is 7 volts, yeah?
Can I just say that to I2?
Plus,
To I2.
if are you moving left or right? You're moving right?
This side.
To the right.
No, it's the left.
Ah, so if you're moving left,
Yeah, can I just say to I2 plus?
no, it's a minus. Because the resistor uses voltage, reduces voltage.
But I2 is going the other side.
Is it? I think the current... Oh, sorry, apologies. Yeah, sorry. You're right. The current is going the wrong way, isn't it? So you're right, it's a plus. Yeah. Did we say plus 2I2 here? Or did we say minus? Oh, did we?
No,
Isn't it minus?
Minus.
Yeah, we did minus here.
Minus 2I1.
Yeah.
No, I apologize. I'm sorry. We all made a mistake.
No, I was asking what to I2.
This one. Yeah, but now that I'm talking about it, I now wonder if we made a sign mistake here.
No, I mean I1 and I2 is going opposite way,
Yeah?
and I was asking about I2.
You were asking about I2. Okay. Right, so just before that... No, sorry. This guy... I'll get to that in a moment. I'm okay. Sorry. This guy isn't I2. This one is... This is I1. Isn't it?
Yeah, it's 2I1.
Yeah, so is it plus or minus 2I1?
It's a
Minus 2I1. Okay, so that's fine. And you were saying I2 is going the opposite way.
Yeah,
Opposite to what? I1?
no, opposite to omega resistor.
Ah, but this I2, it has nothing to do with this 2. I know it's in this loop, but when you get to this junction, the current changes. So it's like here, you have I2, you have I2, you have I2, and here you have I3, I3, I3. But you hit this junction and now you get I1. That's I1 now. So this I2 and this resistor are not related.
How do we know that?
Well, it's a bit hard, but sometimes you have to go backwards. So if you look here, this is I1, which means this is I1, which means this is I1, which means this is I1, this is I1, but then I hit the junction, and I1 splits into I2 and I3. So this is I3, and this is I2, and then they combine back to I1. Yeah. It's not clear always.
I'm getting 6I1 equals to 2 and 3I1 equals to 3I.
Alright, hang on, let's check. So, who has two equations for me? Right. Siva, do you have two equations? What on earth went wrong?
I don't.
Okay. Well, let's write down the three equations. So, Siva, give me the three equations. We'll all compare.
7 minus 4I1
Yeah.
minus 5 plus 3I2
Yeah.
minus 2I1
Yeah.
equals 0.
Did you all get this equation? Or you can clean this up to be 6I2 minus 3I2 equals 2. You all have that? Yes? Okay, good. Siva, what's your second equation?
5 minus 6I3
Yeah.
minus 3I2
Yeah.
equals 0.
So that you can say is 3I2 plus 6I3 equals 5. Did you all get that one? Is that right? Yeah? Right, what's your last equation, Ziba?
I1 plus I2
Yeah.
minus I3 equals 0.
Okay. So oh sorry, did I write I2 here? I should have written, this is 6 I1. Sorry, I wrote, that's a 1. Okay. Alright, did you all get these three equations? Yes? Now, what can we cancel here? I2. Yeah? So look, take this guy, and add them. Then take this guy, oh, we should multiply this by 3. 3, 3, 3. So take this one, and minus them. So 6I1 and no I1s. That's 6I1. Minus 3I2 and plus 3I2? Nothing. No I3s and 6I3s? 6I3. 2 and 5? 7. Right, now let's minus these two. No I1s minus 3I1s. Minus 3I1s. 3I2 minus 3I2? Gone. 6I3 minus 3I3. 9I3. And 5 minus 0? 5. Now look, you have two equations with I1 and I3. Can you solve these? Of course you can. So what will I do? Oh look, I'll just multiply this by 2. Yeah? So now I get 6I1 plus 6I3 equals 7, and minus 6I1 plus 18I3 equals 10. And what do I do now? Add them. Cancel. 24I3 equals 17. Do I have I3? I do. What is... Sorry, that's 20... No, 17, yeah. Yeah. What's 17 divided by 24, please, Matt?
0.708.
708 amps. Okay. 1 sec now. Right. How can I get I2? What would be the best one for I2? This guy. So I can say 3I2 equals 5 minus 6I3. If you don't mind, or Chow, I'll ask you, can you just type in 5 minus 6 times Chow? Could you calculate that, please? 5 minus 6 times 0.708 over 3.
.25.
And finally, how can I get I1? If I use this guy, I can say I1 equals I3 minus I2. So that minus that. So 0.708 minus 0.25. What's that, please? 0.708 minus 0.25? Thank you. Cheryl? Thank you. You're very kind. 0.708 minus 0.25. 0.458.
0.458. Actually, I got the different answer.
I got the different answer.
Wonderful, I made a mistake, or you made a mistake. I'm quite hungry, so it's likely I made a mistake. But I wanted to show you something. There's a way you can check this. And we'll see who is right and who is hungry. Okay. There are my three equations. I can type these into the calculator. Watch. Mode 52. So the first equation, watch. 6I1 minus 3I2, no I3s, equals 2. Next equation. No I1s, 3I2s, 6I3s, equals 5. Third equation. An I1, an I2, a minus I3 equals 0. Right. Fingers crossed. I1 is 11 over 24, which is 0.458, which is right. Score 1. Okay. Next one is 0.25. And lastly, 0.708.
Maybe the equation is wrong.
Huh?
Maybe the equation is wrong.
No, there's no mistakes here.
No, I said.
Oh, these equations.
Yeah.
Oh, but you guys gave me these equations. I trusted you.
Can I show the total?
Which?
The total equation. So,
Tough break, kids. I'm not that hungry, it seems. Maybe we should have done this lesson after lunch. Because I know some of you don't have breakfast, which isn't helping too. Yeah. So what went wrong? What was your mistake?
I forgot to divide.
Yeah.
I just missed the number.
I know, that's painful. Oh, your calculator can't do what I did, can it? It can't.
Which one?
This thing I did here.
1 second.
Yeah.
The 6i3 minus 3i2
Hold on.
equals 5. It's not plus.
Which equation? This one?
The second one.
This one?
Yeah.
6i1?
No, the third one.
5 minus 6i3 minus 3i2.
Yeah.
What's wrong with it? This is a wrong equation?
And the next step?
That's 3i2 plus 6i3 equals 5.
I think it's 6i3 minus 3i2 equals 5.
Oh no, because these are both minus. So they come over and make plus. You know, I take this and this to the right. That's a minus and a minus. So I move them to the right.
Maybe my step here is wrong.
Yeah, maybe.
Minus?
That's equal 5.
Yeah, that's equal 5.
Yeah. Here to here is okay. What was your problem, Siva, with this one? Where did it go wrong?
I went wrong with the I2, I3. In one of the equations, I wrote the I2 as I3.
I've done that before. Sure, I did that at the start. I wrote...
The same one you did.
Yeah.
The same one I did it.
Yeah, it's a pain. You know what? It might be easier to, instead of using I1, I2, I3, to use X, Y, Z. Because then you don't mix up the 1, 2, 3s as easily then. Yeah. Shall we continue? There's one more example to do, which we'll probably finish on. It's the last one, so if you can all get this right, that would be a great way to have our lunch. Continuing. So, this is I1, I2, I3. Okay. Again, another exam question. Now, this time you're looking for I1, I2, and E, the voltage here. It doesn't really matter. You can call them X, Y, Z. It's the same deal. 3 equations, 3 unknowns. Right. The only thing I recommend you do, listen, before you start, I recommend you simplify the circuit a little bit. So you might as well put these together as one resistor. How big would that be? 4. And then you should first calculate these and put them together as one resistor. What rule do you use here? 1 over. So before you draw it, first calculate the resistor here and here, and then draw it. But draw it as one resistor and one resistor. Okay, because it's kind of stupid to have another, path here. So this is 4 and this is whatever. Let's calculate it. I'll help you out here. 1 over R plus equals 1 over 3 plus 1 over 6. Is that 3 over 6? Yeah? So R is equal to 6 over 3, which is 2. So you can combine this into a 2 ohm and this into a 4 ohm. You know what I mean, Chow? Chow? You know what I mean? Take these.
I want to take break.
This is the last one and we're finished. Take this and this, put it together as one resistor. Do you know what I mean?
Yeah.
This and this make it 4 ohms. And then this and this, put them together as one. Just one resistor, 2 ohms. Because I can use... Have you done this formula? Or did you miss that lesson? 1 over R equals 1 over 3 plus 1 over 6. Did you miss that lesson?
I have.
I think, did you miss that lesson as well?
I
You saw
have.
that one?
Yeah.
The 1 over R.
That's the,
No, it's the lesson before that.
no?
You missed that lesson. I think so. There's
No, this one?
no, that's for capacitors, not resistors. There's a lesson before this, after this. There's a lesson in between that you missed. After this, but before this.
Okay,
It's called,
Monday?
yeah, I think
Monday.
so. It's called simple circuits. Look. Or is it, what's it called, simple circuits? Yeah.
I know it's Monday.
Look, it's this lesson you missed where we talked about this. You need to watch the video.
I watched. I watched.
But you need to make notes.
Yeah, I didn't.
Oh, you should.
Yeah.
Now, in a minute, I'm going to ask you for your 3 equations.
I have a question.
Yeah.
If in the final exam, I have the step by step is correct, but the final answer is wrong, can I still get the mark?
You can get some marks.
Some mark?
Yeah. It depends on the question, how many marks.
Okay, so I think in chemistry, if the step is correct, I can get the mark, and if I just have the answer correct, so I just can get 1 mark.
It depends on the question. So for some questions it's okay just to have the answer correct. In some questions they want to see the work.
Okay.
It depends on the question.
So that's for this one?
You'll get some marks for the work. But if you just magically get the answer with no work...
But you know, sometimes if I have the 3 equation, I have 2 correct, and another one is wrong.
You get some marks, yeah. You get some marks for having the equations correct. And then you get some marks for solving, and then you get some marks for getting the right answer.
Okay. That's so sad.
That's life.
Could I just don't do this one?
No, it's good. It'll make you strong.
No, I will take a rest.
I know. Toughen you up. There's only 5 minutes left, Chow. You can try for 5 minutes. Then you can have your lunch. Then you can have your delicious noodles or whatever it is you're going to have for lunch.
The 0.5 ampere is opposite direction.
It is opposite to the cell, isn't it? The current is going up. Yeah. This is I1, this is I2, and this is half an amp up. So here the junction rule is 0.5 minus I1 minus I2 equals 0. I think you're starting to like this, Siva. I can tell. You don't have to hide it.
So the total is 2, yeah?
These two, the total is 2,
Mm-hmm.
and this one is the total is 4.
It's 4.
Yeah.
So if we start, let's say, from 7,
Yeah.
and go down and back up, is that minus 8 what?
Now, so you start at 7, and then this is minus e.
Minus,
Yeah, because you're going in the wrong way.
but the current equals up.
Ah, no, you care about how you enter and exit. You're supposed to exit on the positive plate, but you are entering in the positive. I know that. Yeah, no, I know.
Is it 7 minus 11 plus 2 I?
How'd you get the 11?
The big
Oh, sorry, you're looking at it's 7 minus 11. Yeah, well, this is the thing though. Are you doing the big outside loop? Yeah, so my tip was to start at the bigger cell. So I would have started at the 11 and moved left. Now, it doesn't matter though, see, but you get the same answer. So you're starting at 7, yeah? And then this is minus 11.
Plus 2 I2.
Yes, very good. Plus 2i2. Minus 4i1. Correct. See, I told you you're liking this. I told you.
Why is 2i2?
Which one? Here?
Yeah.
These add to make 1.
I know it's
yeah.
2. And why is 2i2 is no...
Minus. Because that's the current. No, but the current is I2. That's I2. This is I2. This is I2. So this part is I2.
Oh, this part is I2.
Yeah. No, because look, this is I1, but then here is not I1, it splits.
I2.
So I3, which is half an amp, and I2.
I2?
Yeah.
After B is I2?
This way is I2, and this way is half an amp. Half an amp.
Ah, okay. So it's like this?
Yeah, this side is I1,
I1,
and this side is
I2,
I2, and this is I3,
okay.
the half an amp, yeah.
The picture is a bit confused.
Well, that's just part of the problem.
Yeah.
Part of the problem.
Okay.
Have we made 3 equations? Yeah, let's have a look at the 3 equations. Siba, what was your first equation? What did you do? A loop rule?
Yeah.
Starting where?
0.
Huh? What? Matt, what was your first rule you used? A loop or a junction? Junction then, was it, Siba? Up the top.
Yeah.
So your first equation is 0.5 minus I1 minus I2 equals 0. So your first equation is I1 plus I2 equals 0. Yeah? Okay. Okay, Siba, what was your second equation? What did you do?
7.
You started at the 7. So you had 7
Minus 11.
minus 11
Plus 2 I2.
plus 2i2
Minus 4 I1 equals 0.
minus 4i1 equals 0. So you went up the top. Yeah. Now I like what is happening here because you'll get minus 4i1 plus 2i2 equals 4. It's 7. Yeah. So you can say minus 2i1 plus I2 equals 2. Now, why do I like that? Because you can just solve these normally like a maths problem. So you can actually figure out I1 and I2 without the need for a third equation. Now look what they ask you to do first. Get I1, get I2. So we might as well solve before we continue. So actually I think it looked hard, but it's easier than the other ones. So I'll minus them. I don't even have to multiply. Look, it's all ready to solve. The I2s are the same. I1 minus 2I1 is 3I1. 0 minus 2? Minus 2. So I1 is minus 0.667 amps. And what does that make I2? That makes I2 equal to plus 0.667 amps.
Why in this question is no I3?
They gave you I3. It's 0.5.
Ah.
That's why it's easier.
Mm.
Question, please ask me.
Why did you? Why is it that I want I2 equals 0.5 not 0?
Oh, thank you. Thank you, thank you, thank you. Is that what you were asking? Yeah, I'm starting to get hungry. I forgot about my 0.5. So this, I'm sorry, this should have been 0.5.
Oh, yeah.
So 0.5 minus 2 is minus 1.5?
Yeah,
Okay, sorry, thank you. So, so that changes this here. So I1 is minus 0.5 amps, and then I2 is 0.5 minus I1. Is that 1 amp? 1 amp, yeah. Thank you. Okay, lastly we have to get the E. So Siva, what was your third equation? What did you use?
7 minus E.
Okay, so you went 7 minus E.
Minus 0.5.
0.5 times 8. Ah, yes, okay. Because it's like, you know, I or. Minus 4. And then here, minus 4I1. Isn't that, yeah, minus 4I1. But we actually know what I1 is. What is it? No, I1 is minus 0.5, isn't it? Equals 0. So 7 minus 8, isn't it? No, sorry. It's 7 minus E minus 4 plus 2 equals 0. So 7 minus 4 plus 2 equals E. So 7, 8, 9, 5. E is 5 volts. So this is a question where the diagram looked harder than the calculations. Because it wasn't 3 variables. The problem was 2 variables plus one variable with E. Whereas in the actual previous question, it was actually 3 variables and 3 equations. Okay, I think that wraps it up nicely. So you can see why I said Kirchhoff is a double lesson. You must learn to love Kirchhoff. So really, do your best. How many questions? You have 3 circuits here to practice at home, okay? On Monday we'll have a tutorial, and then we'll continue on Tuesday. There's only 3 topics left, which we should finish next week, and then we'll have 2 weeks of revision. Nice. Okay.
My brain shall.
Time for lunch. Time for lunch.